let's say that I have an insulator. In an insulator, the electrons are going to be bound to the nucleus. There's not enough energy to rip it away in a normal circumstances. Yeah, I can always provide enough voltage to turn anything into a conductor. But if I have a material here that's neutral, and I got electrons floating around, and it looks like I've drawn more than one electron. This positive, big positive, is to represent the nucleus, and the little negative charges are the electrons going around it. If I introduce it to an electric field, what's going to happen is that these electrons here will going to go opposite the direction of the electric field, but they're still bound to the nucleus. And so what's going to happen here is I've got my positive nucleus here, and then I've got negative charges that are all going to start moving onto the other side. Recognize that these themselves create an electric field, and so this is going to create an electric field going opposite the direction of the external electric field. So what happens here is that I have a bunch of little tiny electric fields opposite the direction of the external electric field, so the total electric field inside here drops because I have the external one, and then in the opposite direction I have these internal ones. Total is less than what we started with. So a dielectric is an insulator that, specifically the times that I hear dielectric used is when we are dealing with an insulator exposed to an external electric field, and therefore it reacts to it. So how much it reacts, how much does it polarize each of the atoms inside, it's reflected in the dielectric constant, which is directly connected to the permittivity of the material. Now, at some point, there's going to be enough electric field here, or there's enough potential difference that it is going to cause the dielectric to break down. And so that's when you get into things like the dielectric strength, and that's when you can start blowing holes through things. That comes from YouTube videos, and if I'm thinking about it, I'll put a link to a YouTube video somewhere so that you can see someone basically exceeding what the dielectric can handle. But dielectrics in a nutshell.